Hey guys, welcome back. For this video, Module 6, Linear Inequalities, Lesson 1, Part A, we're going to talk about solving one-step inequalities. This is going to be a two-part video. You can see our goals are to graph solutions of an inequality, and we're going to solve an inequality using addition and subtraction and with variables on both sides. Okay, as usual, we start off with some vocabulary. We got what is an inequality? Well, it's an open sentence that contains any of these symbols here. Now, one thing you guys might remember, because I think some of you have done this before, is these symbols right here, the greater than, less than symbols. These right here have an open circle when we go to graph them. And these two right here have a closed circle when we go to graph them. Now remember, open means not part of the solution, and closed means is part of the solution. Okay, now that statement, of course, says that one side is bigger or smaller than the other, or it could be possibly equal to. Now, something you should be aware of is that inequalities almost always have infinitely many solutions. Now, it is possible for inequalities to have no solutions. Something new for you might be the set builder notation. This is simply a way of expressing solutions of an inequality. Sometimes we'll just show this, but you may see this on the test, so you got to be familiar with what that is. Now, how do we pronounce that? It's read as all x, that's this first one, and this little line right here represents such that x is greater than 2. So all x's such that x is greater than 2. Remember, this is infinitely many solutions, so that expression captures every possible solution, not just one or two of them. For our first couple of examples, we're going to talk about graphing. So it says if a solution to an inequality was y is less than or equal to, notice the equal to sign 4, okay, this is what its graph would look like. Well, you'd start with the value that's over here, and because we have an equal to on this, we're going to go and show an open circle or a closed circle. So right here on the line. Now, one of the things I like to do is I prefer to put the dot above, but I'm going to do it on the line. And then we're going to pick y's that make this statement true. So we're looking for values of y that are smaller than 4. Well, on a number line, values that are smaller are always to the left. So we're going to arrow this to the left like this. And I prefer to show it up here above, but I believe most people want it on the number line. So either one of those is actually acceptable. If we look at the one on the bottom, it says graph n is greater than 3. In order to do that one, we find -3, which would be right here. Now we're going to put an open circle, because this inequality does not have an equal to, which means we start at this location, but that location is not part of the solution the way that the 4 up here was. Now again, we're looking for n's that are greater than, so on a number line, greater than is to the right, so we're going to arrow this to the right. So all the solutions are found on this side of the number line. Okay, for this next one, we're going to reverse this. We're going to write the inequality from a graph. Now, we're going to start with the dot. The dot right here has the number 5, so I'm going to put a 5 above it. The line itself represents all the solutions, and the variable is the solution. So I'm going to choose the letter N here for numbers. And remember, on a number line, everything to the right is bigger. So when I go to put an inequality on my number line, or for this problem, it's going to open to the right. Now, one thing I still need to remember is because I have a closed circle down here, I need to put an equal to on this. So this ends up being my inequality. N is less than or equal to 5. For the one down here, I'm going to do the same thing, start with the -8, and I'm going to choose N again. I'm going to put it over top of the line, because remember, this line represents all of my solutions. And I'm still going to open my inequality to the right, because everything to the right is bigger. Now, I'm not going to put an equal to underneath, because this circle over here is not closed in. Now, I can read this. I can read this here technically as a solution. I can read that as -8 is less than n, but I'm just going to reverse that around using the symmetric property. So I'm going to call it n, and then I'm going to flip my symbol around. N is greater than -8. Now I would write this as my solution. That way, when we go to write this solution in set builder, we can say all n such that n is greater than -8. So we can write something like that. Now we want to put that to the test. So we're going to solve inequalities by adding or subtracting. So if we look at our first one here, we have a subtraction. So to undo a subtraction, we're going to add. So to undo a -10, I'm going to add 10 to both sides. The 10s will zero out, give me a 0 plus x, which is an identity, is less than, and then 15 plus 10 is going to leave me with 25. So my solution in set builder would be all x such that x is less than 25, and there's my solution. So that works with addition. Now we're going to use subtraction. So to undo the plus 24, we're going to minus 24 from both sides. This will zero out, leaving us with n plus 0, which is an identity, greater than or equal to And then 61 minus 24 is going to leave us with 37. So in set builder notation, the solution would be all in such that n is greater than or equal to 37. We can do this with variables on both sides as well. So in order to solve this, I need to get the variables off of one side and then onto the other. Now my suggestion is to eliminate the variable with the smaller coefficient, which would be this 9 over here. So I'm going to get rid of the 9y by subtracting 9y from both sides. And I'll get a 0 here plus 3, which is 3 is greater than or equal to. Now 10y minus 9y leaves me with 1y or just y. But I'm just going to reverse that over here. So I'm going to write it as, oh, looks like I got an error here. So that's actually not right. This should be all y such that y is, now you see how this is facing away from y? It should still be facing away from y when I reverse it. So all y such that y is less than or equal to 3. Then we move on to the next one. So I want to get rid of my x's. Get rid of the small one. So I got a 7 on the left-hand side, so I'm going to minus 7x for both sides. That'll give me a 0 plus 6, which is 6, which has to be less than, and then 8x minus 7x is going to leave me with 1x or just x. And then I'm going to write that over here. So all x such that x is greater than 6. In that case, right here, when I reverse it around, notice how this is opening towards x. Well, it's also open towards x on this side. Here we have a little bit of an inequality word problem. It says Hassan's wireless contract allows him to use at most, that's an important one, 5 gigabytes of data per month. At this point, he has used 3.7. So at most, he can use 5. He's already used 3.7. How many gigabytes of data can Hassan use during the rest of the month without exceeding his maximum allowance? Okay, so we want to complete the table to write an inequality, represent how many gigabytes of data Hassan can use. Okay, so he can use at most 5 gigabytes. Now what that means, at most, means he can use 5 gigabytes or less. So 5 gigabytes is the bigger amount. We want to keep that in mind. So let G equal the amount of gigabytes that Hassan has left to use. So I want to write an inequality. Well, we know he's used 3.7 and he's got G amount left. So 3.7 plus G has to be, now remember this gigabytes is 5 gigabytes or less. So that's the max. So that's 5 gigabytes. Remember, our inequality is always open towards the bigger one. And since 5 is the biggest value, I've got to open towards it. Now, at most means he can use that amount or less. So in this context, we need to use an equal sign here. And in order to solve this, all we got to do is subtract 3.7 from both sides. Minus 3.7, minus 3.7. And we end up with G is less than or equal to 1.3 gigabytes. So he says 1.3 gigabytes left to use for the month.